Today we're going to look at mathematical calculations and show that molecules and atoms are so small and based on scale and proportion that it's hard for us to comprehend how many atoms or molecules make up the world around us. So here's just a few units that we will use in our description of that today. We are familiar with a meter, a decimeter is a tenth of a meter, centi, which is 1/100th of a meter, milli, 1/1000th of a meter. But now we're going to get down into the really small. We have micros, which are a millionth of a meter, so 10 to the negative 6. We have nanos, which are billionths, and that's 10 to the negative 9. We have pico, which is 10 to the negative 12, or a trillionth of a meter. And then when we look at the nucleus of the atom, we use a femtometer, which is a quadrillionth and 10 to the negative 15. So let's look at this little animation that I have. Here's some things that we're a little bit more familiar with, like a giraffe. A giraffe is about 5 or 6 meters tall. Okay, a double-decker bus, which is, I don't know, maybe 3 meters tall. Here's an elephant. We're getting smaller. Sunflower, a human, which maybe 1.5 meters. Okay, zoom in. Here's a dog, maybe about a half a meter. A little bunny. So we're getting smaller. Here's a soccer ball, maybe about 15, 20 centimeters. Zoom in a little bit more. Here's an apple, 10 centimeters, that is. A mouse. Here is a bee, so we're a little less than a centimeter. Zoom in a little bit more. Here's a ladybug, getting into the millimeter size now, not quite there yet. So getting smaller, smaller. Here's a sesame seed, smaller. A water flea. Here is a snowflake. So now we're about in the millimeter size. A tick. Getting very, 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 very small now. Okay. White blood cell. This is approaching the micrometer, or the millionth. A human chromosome. Yeast. Red blood cells. Some bacteria. Very small. A mitochondria. Getting even smaller, some collagen, some virus. Okay, 10 to the negative 7, approaching the nanometers. Protein. Here's our nano world now, nanoparticles, DNA. Here's a carbon nanotube, 10 to the negative 9, which is a nanometer, a billionth. Getting smaller still, fullerene, silicon crystal. Now we're approaching the picos, very small amino acid. And here is our atom, very small, very, very small, 10 to the negative 12, which is a trillionth of a meter, very small. So can we go a little bit smaller? We can. Let's zoom in, and this is our atomic nucleus, and it is about to a femtometer, which is 10 to the negative 15, so very small. And even smaller, here's our little protons and neutrons. There's our femtometer, 10 to the negative 15. So I hope that gives you kind of a good idea how small atoms really are, way, way beyond our way of comprehension. Thank you.